Welcome to this presentation on mapping socioeconomic indicators using social media advertising data. My name is Ingmar Weber and I work at the Qatar Computer Research Institute. This presentation is based on a paper published in EPJ Data Science, which is joint work with Masumali, Isabel, Ardi, Stephanie, Vedran, Manuel, and myself. I'll leave the reference here in case you want to access the full paper. In this work, we're using Facebook advertising data to map poverty. Here, I'm showing a screenshot of Facebook's advertising platform, where I'm about to launch an advertising campaign targeting people living in a particular location. In this case, the location that I'm looking at is part of New Delhi. And I'm targeting Facebook users of a particular age who are women, who are predominantly using an Apple iOS device to access Facebook, and who are predominantly using a 4G connection to access Facebook. And then Facebook provides me with an estimate of how many of its users match these criteria, in this case 1,200. So think of this estimate as a real-time, no-cost live census over the total Facebook population. This data is easy to collect through official APIs, and so here I'm just putting some references in case you'd like to collect this data yourself. In this work, we explore how this data can be used to map wealth or poverty, so conversely, across the Philippines and India. And so the setup is as follows. So that we start with known data for a set of locations. And then we use this data to train a regression model to make predictions for other locations where we don't have known data. And we evaluate the predictions, again, using sort of the locations where the ground truth data is known. The ground truth data comes from DHS and it consists of 1,200 sampled clusters. Each cluster has about 40 households in the Philippines and 28,000 clusters in India. For each cluster, there's an associated wealth index, which is a summary of asset ownership in the given location. The data was collected in 2017 in the Philippines and between 2015 and 2016 in India. The Facebook data that we collected is from 2019. Just a quick note that there is inherent noise in the ground truth, so it's not necessarily gold standard. So one source of noise is due to sampling noise. Another source of noise is due to spatial perturbation, where to protect privacy, DHS does not report the true location. So we estimate that the sort of ground truth only explains about sort of 84% of its own variance, if that makes sense, and it's explained in the paper. So this gives like an upper bound sort of, so that no method out there should be able to explain more than 84% of the variance in this data. The features that we are using are as follows. So first, we are looking at Facebook penetration. Here we're using both the Facebook user estimates, as I showed earlier, but then also for the denominator, we need to know the population size in a given location. Here we're using data from WorldPop. Then we're using features related to network type and also operating system, in particular Android and iOS. And here just a quick word that that usually you would expect Android plus iOS to cover all Facebook, all mobile device users. This is not the case due to two reasons. One reason is that it seems that some very low-end Android devices are not necessarily classified as Android, but then also that these are only users who predominantly use a particular device. So users who use several devices will not be included in this count. We can also specifically target users who primarily use a particular device, in particular high-end devices, let's say Galaxy S9, which was a high-end device when we did this study. And then we have similarly other mobile phone manufacturers. And here I'm just showing sort of the correlations, and among other things, you'll see that generally higher Facebook penetration indicates a higher wealth index both across Philippines and India. But some of the other patterns are not necessarily consistent, whereas 4G usage in Philippines indicates higher wealth. In India, it's not correlated at all with wealth index. That's the features. Then what's the regression method we are using? So I mean, overall the regression setup. So using the features X, we try to predict the target variable Y, and so we have to fit a function F that does so. Here for this work, we're using gradient boosted regression forests that are basically sort of like a set of individual regression trees that are then in the end average. And this worked better than using linear methods for this work. And again, I'm showing some details in case you'd like to sort of re-implement things. We're comparing this with one baseline, which is as follows. So suppose you didn't know anything at all about the location here in the middle. Well, but you still know something about locations nearby, and then you could just average nearby locations to make a prediction about the middle. And then you could sort of augment this, and this actually works, quite well. You get, quite decent sort of correlations, right? And then we augment this additionally with throwing in Facebook features for the location in the middle. Okay, so how well does this approach work? So here I'm showing results disaggregated by the feature types. So first here in the first row, you have this interpolated DHS features that I mentioned, where basically you just look at the sort of nearby values to then interpolate to the given location. And this explains about sort of close to 50% of the spatial variation in the Philippines and sort of about 65% of the spatial variation in India. If you use only Facebook features, nothing else, this improves on this quite a bit in the Philippines, but actually is worse than this trivial baseline in India. And then if you combine Facebook with some other indicators, including population density, you get something that improves on the baseline in all cases. And if you further sort of combine it with the baseline, you get marginally small additional improvements. Although maybe in India the additional improvements are not so small. One of the advantages of this method is that you can, of the data set I should say, in particular of the data, is that you can also make gender disaggregated predictions without having gender disaggregated training data. So how is that possible? Well, we train a model on making gender agnostic predictions, but then this model is then applied to only the sort of user counts among women and only the Facebook penetration among women, etc. So doing this, you can obtain a graph as follows. So in this plot, this is for the Philippines. Each individual data point is one of the 1,200 DHS clusters in the Philippines. On the y-axis, we're showing the predicted wealth index for women, and on the x-axis for men. So here in the sort of top left, you have clusters where the method predicts women to have a higher wealth index than men, and conversely in the bottom right. So this was actually first surprising to us to see that there seems to be so many points close to the equality line. So is this even plausible? We're still not sure, but at least there's some evidence that this might be plausible. So in the Global Gender Gap report, the Philippines are actually ranked quite highly across a number of dimensions. And for things such as professional and technical workers, actually there are more women than men. And similarly for legislators, senior officials, and managers, there are more women than men. So at least plausible that in terms of this wealth index, women are generally doing similarly to men in the Philippines. But again, we don't know for sure. Here I'm showing a similar prediction that's disaggregated by education level, where in this case, people who have a self-declared university degree, according to Facebook, or areas where there are many such people, are doing quite a bit better than people where that's for which that's not the case. And this makes sense and is probably as you would expect. What are the key takeaways? So first, again, the data that I showed is anonymous and it's very easy to collect. You can easily write a program that gets tens or hundreds of thousands of these data points. In terms of feature quality, we find a very, very good predictive power of Facebook penetration already by itself, but then also information related to the particular devices that are being used to access Facebook. You can make such predictions that are demographically disaggregated. For example, I showed examples for predictions that are disaggregated by gender or education level. And also in other work, we find promising evidence that it's worth combining this with satellite imagery because there seems to be some complementary strength. There are also some challenges in using this data. So one is that Facebook, for understandable reasons, doesn't give you individual user count, so you can't drill to individual users. So that means that once you drill down to a user population that's smaller than 1,000 users, you sort of hit a notion of k-anonymity. So in very low population areas, this method will fail. So in particular, we had to drop about 1% of DHS clusters for that reason. And probably these are the most rural and probably also poorest areas in which we couldn't do this, again, due to the low population count. The model is also unlikely to have long-term stability. I mean, Facebook uses changes, and I'm sure that 5 years or 10 years from now, it will be very, very different from now. And so definitely you'll have to sort of retrain your models over time. We're also unsure as to whether this model will catch changes across time. Conceptually, it can. I mean, if people, sell their mobile phones or something, or sort of or so, but in practice, this might not happen, right? Especially even as people lose their job, they probably will likely hold on to their mobile phone or not. We're not sure, but we think that's probably the case. Last but not least, there's a public data visualization that I invite you to go and play with. I'm showing the URL here, and there are also 2 other visualizations for which you see the URLs further down the screen. If you should have any questions or comment on this line of work, please don't hesitate to get in touch. So my email address is iweber@hbku.edu.qa, and there's also a list pointed to my publications and presentations, where I will also upload these slides there. So if there's anything in the slides that you'd like to see, the slides will be uploaded here very shortly.